So I'm doing my presentation on underwater flight, which is the next frontier of ocean exploration. So I'm doing this for the NASA STEM Fellowship, which I actually wasn't sure I was going to apply for at first, but I'd seen posters advertising it, and I heard my teachers all talking about it. So I eventually did go ahead and decide to apply. I managed to write a good essay, and of course I had good grades, so I was picked by the selection committee. It was really an honor to be picked as part of the first cohort of STEM fellows at Brookdale Community College. So this fall I'm majoring in aerospace engineering at Rutgers University. So because of that, I originally started with an air traffic control project at Rutgers with the new next-gen system, which is actually going to be able to replace the old radar-based system for air traffic control with a satellite GPS-based system. It'll allow aircraft to fly much more efficient routes. That way you reduce fuel burn and save the environment, as well as increase airline profits and increase safety. So an interesting fact, these pictures are of the Boeing 777, which actually has the largest diameter turbofan engine on any commercial aircraft. I do want to design jet engines with my aerospace engineering degree. So an interesting fact, this plane is actually certified for ETOPS, which stands for Extended Range Twin Engine Operational Performance Standards, and it basically allows the plane to fly over the ocean far from any airport. Basically, to put it in layman's terms, ETOPS means engines turn or passengers swim. So when the air traffic control project didn't work out, due to the fact that I didn't have the necessary programming experience, I got in contact with the Are You Cool lab at Rutgers. That's Rutgers University Coastal Ocean Observation Laboratory through Professor Mike Casani in the engineering department. So at the Are You Cool lab this summer, I'll be working with a cohort of students from a number of colleges, including the Naval Academy, which is appropriate for a lab that involves oceanography. And there I'll be supervised by Professor Scott Glenn. He's in the oceanography department. So now for a little history of submarines. The concept was developed 2,000 years ago for military use, and it's found in both Greek and Chinese literature. While he wasn't writing about philosophy, Aristotle wrote about submarines. So the first modern-day submarine was built by a Dutchman, Cornelis van Drebbel, in 1620. It was encased in leather with wood frame, and it was powered by oars. So, progressing to even more modern times, submarines have been used in the Navy since the Revolutionary War. The first attempted sinking of a foreign ship with a submarine was when the Turtle attempted to sink a British ship with a time bomb. Unfortunately, it didn't succeed. But one sinking that did succeed is when the Confederates sunk a Union ship, the Housatonic, during the Civil War. these early submarines were powered by hand cranks that actually turn propellers. We've come a long way since the hand cranks. First, in the early 1900s, they had diesel-electric submarines. So basically, they'd come to the surface to run the diesel engine, and then that would power a battery, and the battery would allow the submarines to move underwater. It's actually still technology used in some submarines today, but the more common application of diesel-electric motors is actually in the hybrid buses you see in cities. Those have a diesel engine that powers an electric motor, and then the motor is what actually turns the wheels. The US Navy eventually progressed to nuclear submarines, which is all they have in their fleet now, in 1954. And then, after a bunch more technological advances, we finally got to unmanned underwater vehicles, such as the Slocum glider. It's built by a company called Slocum, and it's powered by electricity. It changes its buoyancy when it's in order to move, and that uses less power than conventional propulsion with the propeller, because you don't actually have to power a rotating motor. That allows more power for scientific instruments, which are the main purpose of the glider. When you're underwater, you need a battery, and there's only so much battery capacity, so every amount of power you can conserve is really good. The only things that it has to power are a hydraulic cylinder to move water in and out to change the buoyancy, and the control surfaces in order to make the sub go up and down and left and right. And the subs are autonomous like drones, but they do have a satellite navigation link that also allows them to phone home. So here's some pictures of the glider. If you notice, it looks like an airplane, right? With the tail, the wings, and the way the fuselage is designed. But what's missing, of course, is a propeller or other type of engine, because as I mentioned, it just changes its buoyancy and goes up and down, and also follows ocean currents in order to move. So the RU Cool Lab is involved in a bunch of cool projects, hence the name. One of their projects involves monitoring the Atlantic Ocean. Gliders from a number of institutions, Rutgers included, are patrolling the Atlantic Ocean for the Maracus program. When they patrol the Atlantic Ocean, they're taking measures of biodiversity, ocean temperature, both at the surface and far below the surface, basically to find out the effects of climate change. Maracus stands for Mid-Atlantic Regional Association Coastal Ocean Observation System. Try saying that 5 times fast.
Try it.
Yeah, seriously, try it.
Let me see you try it.
Mid-Atlantic Regional Association Coastal Ocean Observation System. 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 There.
How you doing? No, it's okay. I give up.
So, Are You Cool is also mapping the oceans. They're sponsoring a program to do this using the gliders. And basically, well, it helps us figure out what's actually down there at the bottom. It also is intended to get college students involved in oceanography. If you think about it, When you think of STEM fields, you think engineering, mathematics, chemistry, maybe physics, maybe a few other sciences, but oceanography doesn't come to mind. This project is trying to change that drastically so people actually decide to go into oceanography. So they've done some cool projects in the past too, such as multiple voyages across oceans, and they've also studied the effects of global warming in Antarctica. So they've tried to cross the Atlantic twice. The first time, they got most of the way to Europe, but they lost the glider near the Azores Islands. So, learning from their experiences, they made a second attempt, launching from Tuckerton, New Jersey, and they made it to Spain. And they just collected the glider right off the coast of Spain. So they then got more ambitious and sent the glider around the world, and it visited every continent. It called at ports in New Jersey, Brazil, Sao Paulo, Brazil to be exact, Cape Town, South Africa, Perth, Australia, the Azores Islands, which, in case you don't know, is a British territory in the South Pacific, and the Canary Islands, which are not too far from the Azores, right off the coast of Europe.
Was it recharged each time?
I believe so. So then you have the mission to Antarctica. They had gliders explore the area off the Antarctic coast to observe effects of climate change. They observed levels of phytoplankton, which is basically the basic food that powers the ecosystem, and they studied the behavior of penguins. Climate change does not have good results, but then again, everyone probably knows that. So here's a bunch of references I used in no particular order. Here's credits for the pictures. The pictures of the aircraft were actually my own. And that's my presentation. It's cool, right? Are you cool? Are there any questions? Yes.
How big is it, like lengthwise?
So, I believe it's about from where I'm standing to that whiteboard.
Okay.
Any more questions?
How deep does the glider like swim?
It can go pretty deep. Like, you're measuring it in the tens of thousands of feet, I believe. Yes?
Sorry, one last question. Do
It's
you
fine.
think that with technology developing, do you think they'll be able to use it to explore like the lower, like the abyss of the ocean, or?
Of course. The
Okay,
abyss of the
like-
ocean has already been explored by submarines, or rather submersibles, because submarines would be crushed under the intense pressure at places like the deepest place in the ocean, Challenger Deep,
Yeah.
where actually, I believe only 3 humans have gone. So basically, they'll need to make a lot of improvements before they can do that.
Yeah.
But I believe it's a goal of theirs. Yes?
How many submersibles do they have in their fleet?
I'm not sure, but I think it's somewhere around 3.
And will you be working with one in particular? Or just
Unfortunately, I don't have all the details of the project yet, so I can't answer that question. I'm hoping to find out more in the coming days. Any more questions? None? Yes.
Awesome. Okay. Do you have like a personal goal as far as like what you're studying to use with these? Like, do you want to like something in particular? Do you want to discover or explore more? Or?
Yeah, I want to explore the principles of flight and how they're applicable underwater. Unlike when you're flying in the air, where you actually need powered flight, because A, you're overcoming the force of gravity, and B, there's no buoyant force of air to help you. Well, I shouldn't say that. There is a buoyant force, but it's so small, it doesn't really overcome the effects of gravity. On the other hand, gliding in the ocean is a whole nother animal, because you have a big buoyant force, which is why the glider works just bringing air in and then bringing water in. Changing its buoyancy basically makes it rise and sink. And you're going with gravity when you're trying to go down, of course.
Yeah.
Yes?
Does it have like a little cylinder of compressed air, or does it shoot air out and have a vacuum when it or shoots water out, rather?
I believe it shoots water out and then has air when there's no water. So basically the water goes in and out, because think about it. If you're underwater, how would you get more air in?
But you can't.
Exactly. And compressed air is still air. It would affect the buoyancy.
I'm not exactly sure how they have it working out, but if you can press the air, then you can have this whole column full of water, right? And then you can shoot all that water out and move just the volume. The volumes was important, right, Adam? So you could have the compressed air just distribute into this region.
Yeah.
From my understanding, the way that it's moving through the water is that it's increasing its buoyancy.
Yeah, and
so
then
it's moving up,
decreasing.
and they tilt the wings in a way that causes the aircraft to move in this direction. Am I correct in assuming that?
It's not necessarily an aircraft because it's underwater. It has no capability to fly in the air.
Thank you. Do you understand my question?
Yes, I understand your question.
Is that how it works? It tilts the wing in such a way that when it's moving upward, the wing is pointed in a way that has it move forward while it's moving upward?
I don't believe so. What I believe happens, you have the buoyancy change, which basically changes the direction in which the thing's traveling. So when you put more water in, it immediately starts going down. Take water out, it starts going up.
Right.
And then it uses that sinusoidal motion in order to propel itself.
But that gives you momentum in just your Y, right? So you need momentum in the X.
Yes, and currents help provide that. But if you're doing a sinusoidal wave, you're also displacing water, and the displaced water can help you move.
Right, so that's where the wings come in.
Yes, because have you ever dropped something into a body of water? The water doesn't just get displaced in the Y direction, right?
Right.
Or in that case, it would be the negative Z because it's 3 dimensions.
Yeah. But it's symmetric in that case. Okay, all right.
Yes.
You've answered my questions.
Any more questions?
Can it be that they want to use the gliders for like, I don't know, the next 10 years to, I don't know, to fight with them, like for the war, or just exploring?
Yeah, of course. The military is trying to develop that technology. Why wouldn't they? Anything that gives our military an advantage is a good technology. You always want to be prepared for war, even though you hope it doesn't break out. Any more questions? None? Anyway, it's been good presenting to you guys.
Thank you.